everyone. So there's three of us. There's Sydney and Payton, and we are a team, and we worked on this project that we're going to talk to you about, and also the next one. So we won't have to do the introductions twice. This project is about the south pole of the moon, and it's connected with the Artemis mission that will survey the south pole of the moon, and then a year later they will try to land there and do some extra vehicular activities, and also get a good feel for what it is. This is a very strategic element of the lunar exploration, because there's a potential to find water and a potential to find, of course, there's a little bit of light, not very much, and a potential also to find titanium. So that could be an interesting place. It's much more difficult to be on the south pole of the moon than to be on the equator of the moon, where most of the Apollo missions were. And we developed this project with Frank Wróblewski, who couldn't be here today. So I'm going to try to do my best to go over his part. And this is what I was talking about. So these are the sunlight. Sunlight is on the rim of the craters, and then the water and the ice is on the bottom of the craters. So the exploration is pretty complex because the craters are very deep. They could be about some between 3,000, 4,000 meters. There are really some questions about how you get to the bottom of the crater to get the water. And the rocks could have some minerals also. So it's a sort of a free level exploration. The other complex element is the lighting. And unlike the Apollo missions, where we could have a really good lighting environment, and there's a lot of photography that took place there, or some TV shots that were, this is a sort of black and white lighting, and to a point that you can be sometimes completely in darkness, or you can be also with overexposed light so that you actually don't see where the crater is or where the accidents are. So this is really a problem that made us to be helpful to what Frank and his group was working on, because we do lighting. That's our thing as a virtual technology and design. So we look at that, and other elements also that were difficult for them is the size of the elements that we find there. We find boulders and we find craters, and you can see the size here is indicated less than 10 meters. So that's something you don't see when you have pictures from a satellite, and that's something that can destroy a rover. So we began to work with Frank Wróblewski, and who later with the NASA group that is doing visualization for the Artemis mission. We began to work on the idea that we could actually analyze pictures and use some kind of AI or machine learning to recreate obstacles that cannot be seen on satellite images. And NASA was very interested with that. They are still interested, and we are doing collaboration with them. So these are, this is a 1 meter per pixel picture, and these are images that are analyzed using machine learning and used also for training of the machine learning system. And you can see the little dots in the middle, trying to identify not only the geolocation of the craters and the boulders, but also the typology of debris around them. So this is what we began to create using using machine learning, and you can see the back and forth here Obviously, we could not describe each object one by one. So we used a procedural method to create code-based debris that would be, we call it procedural generation of content, PGC, and the debris are created from the analysis of the satellite image, and also the craters are created the same way. So that's a lot of the work that I did with Sydney and with Payton, which was to create a process where we could generate something that actually cannot be seen from the satellite images. So this is how we also bring the boulders. You can see those little curves. The curves are procedural curves that are actually generating the obstacles or the elements that will be encountered by people when they are on the surface of the moon. It's also, because it's completely procedural, it can be updated very quickly when more data is available. So, and that's the idea. One idea behind the project is that we analyze using AI the images as they come from the different passage of the satellite, or later of the vehicles that they will have. And then we are generating real-time imagery that could be used actually in a spaceship for the training of the astronauts before they get on the surface. So they could be trained the day before, they could be trained hours before with something that is relatively accurate with what they're going to encounter. So you can see here the way we generate different kind of elements, from the rim to the boulders to more distant debris, and see a 3D version of that here. This is another part of the work, which is also using AI, but this time to try to erode the craters so that they look like craters from the imagery that we have. It's very speculative at this point because we don't have a lot of information there. And this is how we create tessellation for those craters. So this is, again, the work of our team to take the geological information and turn it into a mesh information. And I think, yeah, we have a video here. You can see how we change the heights of the craters according to, there are some equations that make a relationship between the depth of the crater and the diameter of it. So we use all that information to try to create an eroded version, and then we light it with the sun, which is about 6 degrees above the horizon. And that's the kind of lighting that we expect people to find when they are on the surface of the South Pole. And you can see it's not very much light. So it's going to be really tough. That's what I was saying at the beginning. Really tough for people to drive in those conditions. Also, when they are facing the sun, it's going to blind them. And when they are in total darkness, they could drive inside of a crater, a small one, and get stuck there. So a pretty stressful situation. This is the result that we got. And you can see that we played on a lot of rendering textures, including the height map or the height field that you can see on the left, which give really the feeling of the dust at the surface of the moon. These are pictures that really were very well received by NASA. And you want to talk a bit about the rover, both of you?
Yeah. So part of the research we were doing with this sort of thing is not only just to visualize sort of what's happening on the moon's surface to a point which is quite accurate to the information we are given from the satellite scans, but also have a way to directly interact with said terrain, mostly in the case of training astronauts who may be going on these Artemis missions, to where we create a virtual rover that is able to be driven around, that can interact properly with the bumps and divots that are found on the surface of the moon in a way that makes training and exploration a lot more intuitive and a lot more interesting than just sort of flying a camera through it.
And you've been working on this, Payton, right?
Yeah, I've been working on a lot of the spline-based techniques we've been using, like what you just saw in this video, whether it's manually placing splines to dictate where the crater is, depending on whatever data we're getting from those images of the moon, and then spawning another spline around that, depending on, let's say, what angle the rocks hit the surface of the moon, dictate where the debris of the rocks are on whatever sides of the craters. You may see some more footage of the rover, driving through here. We were also experimenting a lot with kind of this virtual version of the rover where we were playing with the best spots for cameras that would work for the astronauts or whoever's piloting this thing. So especially with limited lighting, we wanted them to have freedom to look at different angles of the rover. So there's some from the point of view of the astronaut, and then there's also some from the sides and a top view of the rover in case they need some more data before they move forward to really get a hold of their surroundings. There's also some collisions with the rocks that are being spawned procedurally, and those also affect the way that the rover reacts. Like we have a simulated suspension on the rover. This one's kind of bare bones, but the idea is to match whatever is going to be used on the mission, just so it's as accurate as possible. We also have diving into the bottom of the craters. You probably wouldn't do it like that, just a straight shot. So we're also doing training of our own, trying to figure out how these astronauts would actually navigate from the crater rim to the bottom of the crater, because that's where they're going to try and look for sources of water in the sand. I think I would call it sand, and the dust on the surface. So that's a lot of what I've been doing, is just a lot of rover simulation and getting it to work with the rocks and such.
So our next step is to take that this was done in Unreal, and we try to take it into an environment where it could be distributed with low power, low bandwidth equipment, especially if we want to put the simulation on a ship somewhere, or spaceship, or some kind of a location around the moon. We need to have very low bandwidth, which is not the case of those files, which are pretty big, and also low power, which is not the case of the equipment that we use, which is like 100 watt plus GPUs and stuff like that. So that's one challenge that we are working on now, is to go to 15 watt equipment to be able to power this. And anybody who has an idea is welcome to tell us how to do it. Okay, that's it for the little rover.
So you mentioned the problem of low light. Can you just put big floodlights on the rover and then you can see everything?
You did try that out.
Yeah.
Not sure what the verdict was.
Actually, we can do that. The next step that we were asked by people over there who are, I guess, doing that every day. So they wanted to see what would be the reflectance of the suits of the astronauts in order to light the environment around them. And that's something that it's really fascinating, because it's a field where it's very competitive, of course. So everybody is coming with a new idea every week, right? And then there are the ideas that stick and the other ones that don't stick. So I don't know exactly how that idea is going to stick, but the prime of the flashlight or the headlights and all of that is again prime of electricity and power. You know, like if you can do it without it, it's great. One of the things I discovered, we spent a couple of days over there with the NASA team, and it's really wonderful the way they do it. There's not been very many people going there. Actually, nobody has landed there. Even the Indian spaceship that landed close to the South Pole didn't land on the South Pole. It was much more, I don't know if you say north of the South Pole, but anyway, it was not on the South Pole. So nobody has been there. So it's really difficult to relate to the memory of people who've been from the Apollo mission. They have a good memory, but they are not too young, right? And they come to the simulation and they look at it and they say, that doesn't look exactly like the moon, right? So it's a really strange area of, especially about lighting and look and feel and those things like that. And all the information is really from the 70s, beginning of the 80s. So, yeah.
Yeah, how did you get more terrain data?
Here you go.
Oh,
Can you repeat the question?
terrain data to Unreal. That's a good question.
Yeah, how did you manage to get your terrain data into Unreal Engine?
Yeah, okay. Payton's gonna tell you.
So Frank would have more information about it, but he's not here. But he has his machine learning programs that get images like photography of the moon's surface, and that maps out the craters. And the way it maps them out is it gives you little ellipses, little circles, or rather half circles that get filled all the way around. And he also takes all that data and he exports it as a really huge height map, which, you know, a pixel that's white is going to be the highest elevation, and a pixel that's black is the darkest elevation. And Unreal, all the stuff we're using, like the procedural content, rocks being spawned, works with its landscaping tools. So we have to take that height map and load it onto the landscape, which is pretty straightforward. It's kind of hard because they're such big files, but you just have to tell it how high is the highest value and how low is the lowest value, and then it fills in all of the grays in between. And then that's kind of the base layer that we spawn our craters on top of that, the ones that you can't see from the image. And then from there you go into the rocks and debris.
So the height map is, I think the one that he used is 300 gigabytes. And that is big. And there's about 13 different sites of landing that have been spotted. So it's 13 times 300 gigabytes. So this is another world of data, right? And we created also this little floating brush that was created by AI, and which is a floating image that goes over the location of a crater and reconstructs the sort of the erosion of the crater, so they don't look too new. And they like it. They like the erosion part of it. Yeah.
This was for planning out rover routes. So has the rover gone through any of these routes that you've done?
Actually, we're trying to stay away from where the rover goes and all of that, because that's kind of I wouldn't say secret, but they don't want to share too much information about it. So we are completely theoretical in all what we do, and we don't refer to any site in particular. But if one day they give us information, well, this will be applicable. And that was kind of why we did it that way also, is that it's because there's 13 different sites, and I understand I'm not sure if I'm right to say that, but they're going to decide close to the moment of the mission which site is going to be used. They might even switch as the mission goes on, right? Depending on the conditions of things. So we can just grab the information, and because it's procedural, we can create the map right away. Right now, it takes weeks to do that, and we can do it in real time. But it's very difficult to explain that to people because they don't get it, right? So I'm happy to have you guys as an audience because apparently you get it.
Okay, I think then.
Thank you.
Yeah, yeah, let's pull it up here. Yeah. Coming back to Earth, it looks like, for our next talk.
So this is we did that at the same time that we were doing the NASA project. So, you know, I don't know if you do that in your field, but in the VTD, virtual technology and design, we tend to reuse the same technology for something else because, you know, so this is about wildfires, and that's a project we did with Heward from CNR, and we are also doing this project with Ken Udas, who is the Vice Provost for Online Learning. And this is a project to do a metaverse for the university. So just imagine that you pull a switch, right? And boom, the whole university goes online. Not online, in VR. So that's a piece of it. We are not totally finished yet. But so the idea is that there's an experimental forest, which is near Potlatch, between Moscow and Potlatch. And it's great because people can be trained in real situations, but you have basically to burn a piece of forest to train people. So there's another problem, which is that to get firefighters to come to Moscow for a couple of days is a nice idea, but what happens in the communities where they left, right? So training has to be done basically where they work, because that's where they are needed. And so we found this compelling to do a virtual reality environment. We decided to really go all the way with Heather and to do a fire where we would involve students, drones, an instructor with Heather, and we're going to show you some of the development of that. So it's a very realistic environment that takes the students into the reality of the fire and the dangers of the fire. It actually has sound to it, and they can look at things from the top, from the drone perspective, or they can actually walk through the dangerous areas. So we have also created an area of the forest which is after the fire. So there's 3 moments in the forest. There's the healthy forest, there's the burning forest, and then there's the after the fire forest. And this is really important because the training doesn't stop with obviously taking care of the fire. I think this is a video here. So this is showing you a little bit our process. We created, and that's something that you worked on, Payton, right? Created the burning flames, and we wanted people to have a perception of the experiential perception of the scene, but we wanted also for people to be able to perceive the whole situation from a mapping point of view. And that's what we showing you there. So as before you were in that clearing area, we created those interactive widgets so we can actually burn the forest and show you the edge of the burn, for example, or you can see the result of the healthy forest being burned. And all of those elements are completely interactive. So you can experience that on different kind of topography, and you can also Do you want to talk a bit, Payton, because you developed that part?
Yeah, this was trying to dictate different phases of the burning forest. So we're again using this baseline of the topography. In this case, it's the LiDAR data from the experimental forest. We have this base. What you see on the full screen is the healthy forest. We can change the density of the trees, the density of the debris on the ground and all of that. As a starting point, we have another spline on the left with a clearing. So this would be something that's like a past burn that has since, I guess you could call it healed, or, you know, it's not a fresh burn anymore. And then in the middle is this spline where we can control where the fire is starting, and that procedurally changes the existing trees that we had there, and kind of converts them into burning trees or burnt trees. And it also changes the texture of the landscape underneath. And then we have another spline that is just the freshly burnt forest, which is in the middle right now. And these kind of all have a hierarchy over each other, depending on what order they would happen in real life. So you can kind of stack them and overlap them, kind of tell the story of healthy forest burn, or adding the fire and then ending with the burnt trees.
So this is the part where we wanted to build a story with it, and we wanted Heather to introduce us to that, to what Payton was explaining and the tools. So we created this sort of outlook that they use to watch for the fires, and we introduced a character as somebody who would interact with the students, and the students can be up to 50 students in the virtual world. They can be from all over Idaho, but also there's no limitation of where they are. They could be nationwide or in the world. And the lesson starts with Heather explaining about the fire over there. The students in this case have each of them has a drone, and they can fly around Heather, or they can also fly towards the fire.
Three main elements: fuels, weather, and topography. Let's take a look at how each of these elements impacts fire behavior. The first one that we can see from high up is the topography. We can see that some areas have steep slopes and some areas have flat slopes. When fire is on a flat slope, it's going to move slower than when it's on a steep slope. Fuels are what's burning.
So this is the drone
Living
of a
fuels
student.
like trees and shrubs, and we've got dead fuels like sticks and cured grass. And when fire moves into areas that have dry, cured fuels, it's going to move faster and burn with more intensity. When it's burning into live fuels, it might have lower flame lengths. And then the third element is the weather. And the weather is the most difficult element to predict because it changes all the time. When you have sun shining on fuels on the ground, it dries those out, makes them more available. And of course, when you have rain, it makes them more wet. And so again, those three main elements, fuels, weather, and topography, you change any one of those and you're going to see a change in your fire behavior.
So that's kind of an experience. We call it experiential learning, right? It's you are with the teacher is flying with you. You fly from this outlook so that you are not actually physically there. But then when you land next to the fire, you can be actually on the ground and continue with your instructor, who is asking you questions about what is your equipment, is it safe, etc. And you can interact right away to those questions. This is how it's done. And I wanted to show you, this is a system that we developed here at VTD. This is in real time. So actually she is captured in real time using video, and Sydney's been the expert of facial recognition for that. She's doing live link, which is taking the teacher talking with just a mobile phone and having the facial expression, and the rest of the body is also captured in video, and we get that motion capture to go into the scene. So we can do it real time, or we can also record it and play it back a little bit, you know, if students want to replay the scene, or we can capture it in video like you see. But the goal was with Heather and with other people that we developed.
Welcome to class, everyone.
It's to do it live.
We are going to be learning about fire behavior and about a little bit of fire.
This was done a year ago, so the technology that we developed, you could see the difference between what you just saw, which is a year later.
So let's say that you've just been dispatched to a fire and you've gotten the coordinates for this location and you are going to be flown into the fire, which is super exciting.
So I'm going to skip it. I just wanted to show you the difference and how the technology changes so quickly that we could increase the resolution, increase all those elements that are not as great a year ago.
First thing we're looking at is our
this is how the system works. So we have developed a system with iPads. You want to talk about it, Payton? Maybe?
Yeah, we're still stepping back in time again here before that last video. We're kind of at the same time, actually, where we were experimenting with how the students would be inside of these virtual worlds, how they'd be interacting with them. And we were using iPads and having the students look through the screen of the iPad into the virtual world, because that's a lot more accessible for people. Depending on if you get motion sickness, having a thing strapped to your head, or if you just aren't comfortable with having a headset on, the iPad seemed like to be the most accessible entry point into the virtual world. So we were hosting all of these people with their iPads together in one space, both in real life, but also in the virtual world. But I think this could be applied where the people with the iPads are spread out all the way around, just wherever they are, and then they're being brought together in the virtual world or the virtual forest.
So basically it's like VR, but we're not using the headsets. And that's a lesson we learned also during the pandemic, which was, during the pandemic, it was not possible to share headsets for all kinds of reasons, including possibility of contamination and things like that. So we went the iPad way, and we found out that the interaction was very rich, actually, with people seeing what they see, but they can continue to talk to each other, they can see each other, or they can use other ways if they are not in the same room. This is another project that we developed that is kind of the origin of the project that we're showing you today. This is the river that goes between Moscow and Pullman. And Payton and I, we developed a project for SIGGRAPH in Asia, which is a large conference for computer graphics, where we were selected among 10 of the teams as the best VR environment in the world at that time. And we got to present that project to a large audience where everybody in our team were using iPads to move the camera. And you can see here the environment, which is this Paradise Creek River that you all know it. If you take the highway to Pullman, you drive along that river. So this was a storytelling project, it was not a scientific project, although we scanned very carefully the river at different times of the year. And we created a whole world and a whole environment with the herons. There's a couple of herons that live there. There's beautiful other birds. And we created a story with a lady who is paying attention to the herons and trying to help some of them through their story. So this is a snippet. interaction and guides and flights. Okay, so this is what we wanted to present you today. I think we're a bit slightly over time.
Any questions?
Thank you. Thank you. This is actually really interesting, the fire simulation especially. So my question is, you brought up you can change the density of the trees. You brought up that the LiDAR informed some of the topography. So how have you tied any of the other parameters for fire behavior to that virtual world, or is the fire that we see just kind of flames put on a landscape? So it would be really interesting to see you teach the kids, okay, this is what this fire looks like with low humidity, high temperature. This is what it looks like with a more average humidity, or if we do fuel treatments to this landscape and raise canopy heights or that kind of thing, how does that fire behavior change? So have you tied those parameters to virtual landscape?
We're working with Heather still. The nice thing about having it be a virtual forest is that, now we're playing with having this one landscape and doing all these things to it to see what happens. But we can only really do so much right now at that point, like you're saying. But we're kind of taking the next steps with Heather and seeing what the benefits are of just having like different use. I don't know if I should call it use cases, but having this swath of forest and just having it multiple times in one world, and have one with different tree densities, one with higher canopies, like you're saying. And then I think that's how we would tackle the weather issues as well. Because you can hear Heather giving her spiel about the different things that affect fire behavior happening in the background of that video, but the only one you're seeing as of now is the density of the trees and also the topography. So yeah, we're playing around with that some more.
Yeah, we're moving also in two directions. There's one direction that's looking at what some people at CNR are doing, like looking at the size of the tree or the tree trunks. And actually, they are not interested in what's outside of the tree. They're not even interested in branches, right? They're interested in the volume of the wood, basically, or the logs. So we're trying to connect both. And because they use LiDAR images that show them the density of the canopy and the foliage, and they have to extract from that the logs. and we're interested in the density of foliage. So I think that's a collaboration there that's going to be really rich. The other thing is also what Payton was suggesting is that we are building expectations, and people, like what you said, are coming and say, hey, can you do this and that? And we showed that to the US Forest Service, and now we're hopefully going to start a collaboration with them where they want us to rebuild situations where firefighters were in danger, and to learn from the good things to do and you know, how to react to those situations. So yeah, there's some continuation of it.
Cool. Can I quick follow up? So you're saying that you would have to create basically a virtual world for each parameter rather than have like a slider that parameterizes the world on the fly?
They could turn out to be a mixture of both. And yeah,
It's difficult to do, to be too reductive also with the slider, you know, because when you talk really to the people who are our audience, who is the firefighters, the look and feel, the perception of it, the noise, is really important for them. So I think we are exploring a different way than some really great simulators that have been built, but at the same time, they are not used in the field because they are too cumbersome or too complex, right? So we want things on a laptop. And this is the same logic than what we do with NASA. And I think this is kind of the VTD approach, I would say, is that we try to do things that are, like I was saying, low energy, low bandwidth, portable, can use in the field versus big models. Because when we showed the rover to the NASA people, they were saying, oh, but we have a $10 million simulator for the wheels of the rover. Why don't you use that? You know, but it's not going to work if you are up there, right? So we are interested in those kind of trade-offs like that. But this said, yeah, the flames should be, yeah.
That's kind of the benefit of having these like pre-packaged scenarios, especially with stuff that's training focused, because it's like, okay, here's this really specific moment in time and you have to react to it in a certain way for training. So that's also easier to run on a laptop because it's kind of this little care package that's just ready to go at any moment.
Thank you. All right, thank you.
Thank you.
Our next presenter today is Jason Starace. And you're all set.
Well, thank you. How's everyone doing? My name is Jason Starace. I'm here with Nate Summers. We are actually taking a course CS 528 under Dr. Comte de Leon. The brief description available in the catalog is that it's a software design and programming issues involved in constructing multi-user computer games and virtual environments. What this boils down to is students are given two options: to either build a multiplayer video game environment that they can do what it is that they want with, or they can build a base environment that will then be used the following semester to create a digital twin. This is what we opted for. So what we're actually working on is building out a particular lab within the IRIC that next semester we're going to take and turn into a digital twin, and there will be more on that later. The workflow that we went through, we had a couple of crash courses with Bruce on how to use ArcGIS. We went from ArcGIS into the City Engine. We did use Substance Designer to create some textures. And we also used Maya for building out the assets that we did. And we dumped everything into Unreal. So we're going to go over our process, getting to a point where we have something usable in Unreal. So starting off in ArcGIS, we found out that the library actually had some really fantastic information about the university's campus. So there's 1-foot elevation maps that we had available. So we took that and brought it into ArcGIS, turned it into a contour line map, and then over into a TIN, had everything ready, found out that there is a connection directly from ArcGIS into Unreal, which was going to be fantastic. Make the process nice and easy. We can get started working on building out the campus directly in Unreal. However, when we brought it into Unreal, we found some issues. And we overlaid on top of that just a general map to see if we had everything lined up right. But our biggest issue that we ran into was it wasn't actually a landscape. We had a separate actor that didn't allow us to make the changes or work with it as a landscape in Unreal. So we were kind of back at the drawing board, and that left us wondering what next.
Yeah. So at this point, we were trying to figure out the best option to get this landscape into Unreal. No, didn't even realize that. So we explored a few different options. There is a landscaping plugin directly in Unreal. It's like $150 though per developer. So it was definitely an expensive solution that all it does, it looks like, is basically take a digital elevation model and turn it into a landscape. We realized eventually, though, we could do that with City Engine, and we had access through the university. So thank you for that. This here is just the base elevation model. There's no material added to it. This is just the raw render here. Let's see. Some other use cases for City Engine, you'd see it's used in city planning as well as simulation and just data visualization as well. For us, we just wanted it to get this landscape in off campus. Since we had such good data to make a virtual environment for campus, we decided we would try and use that here. So there is a plugin for City Engine directly to Unreal called Vitruvio. You can get it directly from their GitHub. So at this point, though, we knew our search was over, and we began trying to add data to it to use in Unreal. So besides just using the elevation data from the university, we're also able to pull in OpenStreetMaps data, which has among streets and roads and buildings, lots of other things like parks. Well, in its raw form, there was a lot of those parks and stuff are just static meshes at this point, so we had lots of cleanup to do, and we spent quite a bit of time just removing what we didn't need. But after that point, we moved exclusively into Unreal, and at this point, I'd like to pass it back to you, Jason.
So yeah, on that note, we were able to actually bring in not just the landscape, but an outline of where all the buildings should be. You can see our fantastic City Engine texture up there on the Kibbe Dome. We didn't dive too far into all the textures. Our main focus was the IRIC that we were working on. So we have the basic mapping for any of the roads, pathways that go over campus. We tried to map out some of the arboretums, or the trees in the arboretum, and some of the trees on campus itself. So we do have a little video that's a flyover of the campus that I'll play for you here in a moment. We did work on some of the sounds, but might be hard to hear. And the idea for this, again, this is just setting the environment, creating what we need to later focus on the assistive robotics lab in the IRIC. And this podium is on wheels, FYI. So Nate has done a lot of the work with the splines to lay out the creek, the rivers as well. I found out that, is it Revit?
Yes, yes.
Revit might be a lot better way to process blueprints than taking everything into Maya and building out the individual assets, just FYI, if you find yourself in this situation. But we did build a lot of focusing on the first floor since the assistive robotics lab is there. Tried to add some ambient noises for ambiance, as you would expect while walking through a populated public place. There's the polymorphic labs on the left. So this will be where we're focusing. This little room here, the lab for assistive robotics next semester, we're going to be focusing on building out the exoskeleton, the arm, blue Sabino. So there is Christopher. He's been the point of contact we've been working with a lot in the assistive robotics lab. And those are our next steps really for the project is we're going to do some finishing touches on the environment, make sure we meet the needs set for the project. And then we will work on that digital twin, building out that arm you see him attached to, and that connection between Unreal and the exoskeleton itself. So we can use the collisions that are in Unreal to kind of set parameters that will slow down the physical arm in the world, or work with them on different requirements or things that they might want to have tied between the two. But not sure if I can actually play this video here. That may not share over. So just for some more information of Blue Sabino itself. So we hope to have the virtual representation of that arm available. So this would be something that you'd see physical therapists working with their patients, either tracking the data, and that data flow in between the two also has potential to work with AR or VR with different games that they can use to help rehabilitate patients from stroke. Sorry about that. That's what I get for breaking the norm and sharing that window. Sorry about that. But yeah, for more on that, definitely they're in the IRIC. IRIC, we're just trying to put something together to help them out and learn about digital twin programming. So.
Any questions? We got nobody online. Okay, thank you.